Hello everyone, my name is Ketan Thorat. I am learning in second year of electrical engineering in the Zeal College of Engineering and Research, Nare, Pune. I am going to talk on calculation of residential lighting load guided by Jayanti Venkataraydu sir. Presented by G17 Group of Project Based Learning. The members are Thorat Ketan Santosh, Adode Tirumal Bajrang, Bandargar Vishala Paso, Bosle Shweta Sanjay. In the next slide, main contents, introduction, why lighting design important, relevant lighting terms and formulas, layout of 1 BHK plan, calculations about dialects and output of dialects. In the introduction, we can learn that lighting design is very important because an underlighting arrangement will decrease the efficiency of the task for which the lighting were designed, and overlighting arrangement will result in over expenditure. The simple and basic approach for calculating the lighting requirement is to divide the total lighting requirement of the room by light output lumen provided by a single lamp. In this slide, we can see why lighting design is important. For human needs, visibility, ability to see object and information, task performance, ability to do tasks, mood and atmosphere as well as visual comfort and safety will be good. Common issues are overhead glare, wheeling glare, shadowing, gloom, stroboscopic effect, etc. Here we can see basic terms about lighting design. For room index, it describes the ratio of room's length, width and height. It's usually between 0.75 to 5. Room index is equal to L into B divided by L plus B into HM, where L is the length of room, W is the width of room and HM is the height between the work plane. In this slide, we can see the maintenance factor. Maintenance factor is defined as the ratio of illumination under normal working condition to the illumination when everything is perfectly clean. The formula of maintenance factor is illumination in normal under working condition divided by illumination when everything is perfectly clean. It is less than or equal to 1. 0.8 for offices or rooms, 0.7 for clean industry and 0.5 for dirty industries. Room reflection. Bright colors with high reflectances result in a higher utilization factor. A high utilization factor will mean fewer lamps are needed, resulting in a more efficient energy usage and a lower capital cost. Typical reflectance factor. Color factor. For white and cream color, there is factor of 0.7 or 0.8. For yellow, it is 0.6. For light and green or pink, it is 0.5. For sky blue or a grey, it is 0.4 and for a brown, it is 0.3. Here we can see the manufacturer data with respect to room index for utilization factor in the given chart. In this slide, we can see the utilization factor. It is the ratio of total lumen reaching the working plane to the total lumen given out by the lamp. Utilization factor is equal to lumen received on working plane divided by lumens produced by lamp. The ratio is lesser than unity. It is between 0.225 to 0.5 for direct lighting and between 0.1 to 0.3 for indirect lighting. Here is the layout of 1 BHK room. In this slide, we made the calculations for hall. We made taken the length 3.72 meter and width 4.1 meter, which given in the layout of 1 BHK flat, and HM height is equal to 1.5 meter. By using formula of index, we get the value of 1.3. By referring the data sheet for utilization factor, we can conclude the value of common utilization factor, that is 0.62. The formula for calculating number of light fixture is length into width into lux level divided by the multiplication of common utilization factor, multiplying factor, type of lamp and lumen factor of lamp. 120 is the value of lux level and 1500 is the value of 15 watt bulb which we are installed. After the calculation, we get the value of 2.46, which is nearly equals to 2, and total lighting load for hall is 905 watt. Here is the calculations for kitchen. In this slide, the calculation for dining room. Here we can see the calculations for bedroom. In this slide we can see the calculations for master bedroom clearly. In this slide we can see the calculations for toilet and bathroom clearly. For the project we use the software Dialex 4.13. In this slide we can see the clearly image of 3D view of room. And this room is created in the Dialex 4.13 software. It is 2D view of the room which is created in the software. Here is the output of Dialex software. Thank you.